So when you do partial fraction decomposition, if you do equate coefficients, you'll end up with a system of linear equations like 2, 3, or 4 unknowns with 2, 3, or 4 equations. But there are sometimes some shortcuts that you can take. So here I've set up the equation that we would use to equate coefficients. But before I do that, I notice that if I let x equal 0, I can solve for b right away, because when x is 0, these two terms have a value of 0, and I get 54 equals 9b, so b equals 6. So if I want to put 6 in for b, it turns out that's the only variable that I can solve for by letting x equal some number, because there's a number that's in some of these other terms to a value of 0. But if I put 6 in for b and clear these parentheses, you can see that solving the system, setting up the system really isn't that hard, because look, if you look for the coefficient of x, there's only one term that has a coefficient or a variable with a power of 1 on the x, and that's 9ax. So 9a has to equal 45, a equals 5. And then if I look for the x squared terms, 6x squared plus dx squared has to equal 8. 6 plus d equals 8, d equals 2. And finally, for the cube terms, which I've outlined in green here, a plus c has to equal 9, but we already found out a is 5. So there's your values. A is 5, b is 6, c is 4, d is 2. And here on Desmos, I've graphed two functions using the original expression and the partial fraction decomposition. You can see the graphs are the same. So I'm convinced that's the correct answer. Did we really just solve a 4x4 system? Yeah, we did, but it really wasn't that bad, because I could find one variable at a time. There you go. Hope that gave you some ideas. If you end up with factors over here like x minus 3 in the denominator, and another term has x plus 4 in the denominator, you can do things like let x equal 3 and solve for a variable, let x equal -4, solve for a variable. So that's sometimes a shortcut that applies when you don't have to set up a linear system. There you go. If you have any questions, post a comment.